Okay, so welcome back, and now today we're going to start talking about trig functions of special angles. So the two situations we're going to deal with multiples of 30 degrees, 60 degrees, and 45 degrees. Okay, now since we're dealing with right triangles, keep in mind that this is only good for angles 0 through 90 degrees because again we're dealing with right triangles. Okay, so let's take the first type of triangle, which is a 30, 60, 90 triangle. So 30 degrees, 60 degrees, 90 degrees. Okay. And the equivalent in radians, again, make sure you're familiar with radians. The equivalent to the radians is going to be pi over 6. Pi over 3, and pi over 2. Okay, so these are in degrees, these are the angles in radians. Okay, so now when you're dealing with the unit circle or the circle itself, okay, the relationship depends on the side, again using the side lengths. Okay, so if I create an angle, so let's create this angle here, right? And so this is going to be X, Y, and let's say I've got this triangle that I've created. And so this length here is going to be, it's going to be we'll call it X. Okay. And let's say this is a 30-degree angle. Okay, it's not really a 30-degree angle, it looks more like a 45, but let's say this is a 30-degree angle. That means this has to be a 60-degree angle, right? Because these two have to add up to 90. Since this is 90, that's why we call it 30, 60, 90 triangle. So here's the thing. This is not X. This would be let's do S. Let's just do S because this is going to be, let's do S. Oh, you know what, let's change this to 60. And then let's do S. And then we can change this later. So let's say this is 60-degree angle. That means this is 30. Now, this side here, we're going to call this S. Whatever that length is, we'll call that S. This side here, because it's a 30, 60, 90 triangle, is going to be the square root of 3 times S. So S times the square root of 3. And then the hypotenuse is going to be 2 times S. Okay, so that's the relationship between the three sides. Now notice that obviously S is always across from the 30-degree angle. The smallest side is across from the smallest angle. And the largest side, which is always the hypotenuse, is across from the largest angle. So 2S and S are here. And then the middle side is S times the square root of 3. Okay, so this is the relationship for any triangle. Okay, now if this was a 30-degree here, what if it was a 30-degree angle? The reference angle is 30 degrees, which means this would be 60 degrees. Well, then this would switch, right? This would become S, and this would become S times the square root of 3. Okay? So you just have to remember that pattern, okay, that relationship. Okay, now, the other special triangle is called the 45 degree, 90 triangle, or what we call the pi over 4, pi over 4, pi over 2. Okay, so now let's erase this and let's make it into a 45, 90 triangle. Okay, so let's say this is 45 degrees and this is 45 degrees. Well, the way this works is this is an isosceles triangle. A 45, 45, 90 triangle is an isosceles triangle because the base angles are the same. And whenever the base angles are the same, the legs have to be the same as well, which means it's an isosceles triangle, which means this is going to have length S, this is going to have length S, and then the hypotenuse is going to have the length S times the square root of 2. Now the thing is we can get all of these measurements by using the Pythagorean theorem, right? So we can get all fours. If we know the two sides, we can get the hypotenuse by using the Pythagorean theorem. Likewise with the 30, 60, 90 triangle. Okay, so now for a 45, 45, 90 triangle, this is the relationship of the sides. Okay, so we can use this, right? We can use the fact that we have this. So let's do this here. So if I have a 30, 60, 90 here, and let's have 45, 45, 90 here. Well, we know that this is going to be x, x times the square root of 3 and 2x, whatever, whatever x is. And in general here, we're going to have x, x, and x times the square root of 2. Okay. And so knowing the fact that this is always going to be the case, no matter what x is, no matter what the length of the side is, the ratios are always going to be the same. Okay, so what does that mean? Well, now let's look at the trig functions, right? So sine theta, cosine theta, tangent theta. Well, sine theta here, right, sine of 30, well, let's do 30 degrees, just as an example. Okay? So the sine of 30 degrees is what? Sine of 30 degrees is opposite over hypotenuse. Well, look what happens. It's going to be x over 2x, which just gives me a half. So x drops out. It doesn't matter what x is. The sine of 30 degrees is always going to be a half. It's constant, right? So cosine of 30 degrees. Cosine of 30 degrees is adjacent over hypotenuse. Well, what does that give me? That gives me x times the square root of 3 divided by 2x. Well, the x's cancel out, and I get the square root of 3 over 2. And then finally, the tangent of 30 degrees is opposite over adjacent, and that's going to give me x over x times the square root of 3, which gives me 1 over the square root of 3. Now in this case here, we wouldn't leave the square root in the denominator, so we would rationalize this by multiplying the top and the bottom by the square root of 3. And so we would actually simplify this by calling this the square root of 3 over 3. And so now we know that, hey, if I have a 30, 60, 90 triangle, or if I have a 30 degree angle on the circle, if my reference angle is 30 degrees, guess what? I know these are always going to be my answers, regardless of how big the radius is. The ratios will always stay the same. Have a great day.